Logarithms Properties. The first property I want to talk about with logarithms is the log base b of 1 equals 0. So why does this work? What's happening here? Well, if we rewrite this, right, we start with the base across the equals, equal what's left. So we get b to the 0 equals 1. We've already said b is positive, so it can't be 0. B is bigger than 0, and it also can't be 1. Any number to the 0 power, right, we know that rule is 1. So that's why this is true. So the log of 1, no matter what the base is always 0. The log of 1, whether it's common log, natural log, or any other log, is always going to be 0. The next property, log base b of b equals 1. If these two things match, then it's just the exponent. The exponent there is understood to be 1. Again, let's rewrite it. B to the 1 equals b. B to the first power equals b. Well, what's b to the first power? B, and b equals b, right? So that, again, that makes sense. That's true. So the log base b of b is 1. Log base b of b to the x equals x. So again, let's rewrite it. B to the x equals what's left? Equals b to the x. Well, b to the x equals b to the x. That's, okay, I buy that, all right? All right, let that sink in for a second, all right? And then the last one, b to the log base b of x equals x. Here, we actually have an exponential with a log as an exponent. If we rewrite it, we're going the other way. Write the log first. That's what I do every time, right? Start with the base and go to the other side. Log base b of x equals what's left, right? Well, what's left? Log base b of x. Look at that. Log base b of x equals log base b of x. Okay. So no matter what x and b are, all of these properties hold true. All right. And we're going to use these four properties in a little bit. So if we consider the function f of x equals log base b of x. So we're talking about functions here. So if we have a logarithmic function, I want you to know the domain, right? That's everything x can be. We've already said x has to be positive, right? So it's positive real numbers. It's everything from 0 to infinity if we put this in interval notation. That's how we write x is greater than 0. The range, the numbers that you can get out for the function, whatever you evaluate this, what can it be? It can be everything, all real numbers, negative infinity to infinity in interval notation. They're all real numbers. The x-intercept is always going to be 1, right? Because if you take the log of 1, what do you get? 0, and 0 is the y value, right? So the x-intercept is 1. That's how we find intercepts, so the other value be 0. If x has got to be positive, right, then if you have your grid here, and here's the y-axis, if x is positive, it's always over here. It can't even be on the axis. So there's no y-intercept at all. There's no y-intercept. And then if b is greater than 1, right, if the base is bigger than 1, I didn't mean to do that. If the base is bigger than 1, then the function is always increasing. So the function looks something like this. It goes through this point 1, and it does something like this. Okay, it's always increasing, always going up from left to right. And then if the function is, if b is between 0 and 1, right? Because again, b is positive, but it can't be 1. So notice I don't put equals on either one of these, okay? So if b is between 0 and 1, the function is always decreasing. So here, if we have this, here's the intercept, it does something like this. It's always decreasing, okay? The y-axis is a vertical asymptote, which is the line x equals 0, all right? Vertical asymptotes are x equals, right? So the y-axis is a vertical asymptote of this graph, and you can see it from the images I drew there. That would match with what I drew, all right? So here, if you want to expand to the common log and the natural log, guess what? The log of 1 is 0. Doesn't matter what the base is. Log of 10, right? Log base 10. These things match. Answer is 1, right? Log base 10 or 10 to the x, just the power. And then 10 log base 10 of x is x. These things match whenever the bases match here, okay? So the rules are the same even if it's common logarithm. That's because the common log is just a log where 10 is your b, and it works for every b, so why would it not work for 10? And then here, ln of e. So the ln of 1 is 0, the ln of e is 1, ln of e to the x is x, and then e to the ln of x equals x. Again, if the bases match, these bases match. This and this matches because there's understood e there, right? So the bases match there, all right? So those are the four rules or properties for common logs and ln's. So what we want to do is we want to see can we, well, let's review the other properties before we evaluate these. Log base b of 1 is 0. Log base b of b is 1. Log base b of b to the x is x. And log base b to the log base b of x equals x. Again, if the bases match, then whatever the power is here, whatever this taking log of is here, those things all match up. If you're taking, if these things match, the answer is just 1. And if you're taking the log of 1, the answer is 0. All right? So now let's evaluate with what? Evaluate without a calculator. So here's what you want to do. If you see a logarithm, the easiest way to evaluate it is, can you make the bases match? Or can you get it into 1 or 0, right? The log of 1 or the log of b. The answer being 1 or 0. So here, can I get these things to have the same base? I want the same base for all of these, okay? So here, can I write 49 as 7 to a power? So you can't change this. You want to change this other thing, 49, write it as that to a power, actually, not the same, but can I write 49 as 7 to a power? So then the log base 7 of 7 squared, right? 49 is 7 squared. So maybe over here in a thought cloud, I'm thinking, okay, 49 equals 7 to what power? Oh, okay, it equals 7 to the second power. And you know that. That's one that you know right off the top of your head. You don't even think about that. Well, if these things match, right? If those things match, then guess what? That's this rule right here. Here's your 7, and your 2. So the answer is going to be 2. The answer is going to be 2. So this answer here is simply 2 because those things match. All right, that was the third rule on the page before. So let's keep looking at these. Can I write 27 as 3 to a power? Well, over here in my little thought cloud, what do? 27 equals 3 to what power? It's going to equal 3 to the third power. That's right. So now this is going to be log base 3 of 3 to the third. If these match, this is my answer. Every time. Same rule that I just used on the last one. So 3, it's this 3 that's the answer. Okay, not any of the other 3s. So what about the next one? How on earth do I do this? I need to write this log. Let's see. I need to write this as log base 5 of 5 to something, right? Well, look, let's talk about it over here in my little thought cloud. 5, let's see, 1/5 equals 5 to the, what if I did -1? A negative means take it and put it in the denominator, right? If it's in the numerator, put it in the denominator, or vice versa. So here, if I have 5 to the -1, that means I've moved 5 to the bottom. It'd be 1/5 to the first, and that's exactly what it would be. So if it's a fraction, it's a negative exponent. And if that was 1/25, that'd just be 5 to the -2, right? Because 5 squared is 25. So just if it's in the denominator, negative exponent, and then what power is it to get 5? So 5 to the first power to get 5 here. So 5 to the -1. So again, these match. If those match, then this is my answer. So this answer is -1. I'm using the same rule, that third one, for all of these. In fact, it's going to be the same rule for the next one here. It's going to be that same rule. That's the fun rule, so to speak. All right? And some of you are like, none of this stuff's fun. It's logs. Okay? Log base 6 of 6 to some power. Okay? So over here in my thought cloud, how do I change 6 to a square root? The square root of 6 equals 6 to what power? Remember, roots and radicals, it's the power over the index. There's those understoods, right? An understood 1 power and an understood 2 index. So the square root is the 1/2 power. The cube root is the 1/3 power. The fourth root is the 1/4 power. The eighth root is the 1/8 power. Okay? So that's the 1/2. So this is written as log base 6 of 6 to the 1/2. And again, these match. So 1/2 is my final answer here. Okay? So 1/2 is my final answer here. All right? So let's look at some more of these. Now this one, log base 121 of 11. Now remember, I can write 121 as 11 squared, but I can't change my base. I don't need to change my base. I need to write 11 as somehow 121. So what I'm going to do is say, wait a minute, I know that 11 is the square root of 121. Now it looks like the problem before, doesn't it? The square root of 121 is 11, so I'm going to change that. And then if that's the case, then I'm going to say, okay, this is the log of 120 base 121 of 11, not 11. I want to get 11, but I want to end up with 11. 121 to the 1/2 power. Again, these match, so my answer is the exponent. In this case, 1/2. Okay, this case, the answer is 1/2. half. And then log base 80 of 80. Okay? So a little shout out to the greatest receiver that ever lived here. This is my tribute to Jerry Rice, who wore number 80. All right? I know that's you might think somebody else is better, but he was the best ever. All right? So log base 80 of 80. These things match. There's no power there, but it's understood to be 1. So the answer is just what? 1. This is the rule. Let's go back and look at it. This is the rule, log base b of b. These things match. There's my 80. There's my 80. So my answer is just 1. All right? The answer is just 1. So then the next one, this one, there's nothing to rewrite here. There's no, because look, these already match. I only rewrite it when they don't match. If they match, what's the answer? Boom, that's that third rule again, right? That's the same rule I use on every one of them but the 80 problem, right? And then what about the next one? Doesn't have a base. It's understood to be 10. That's right. That's right. It's understood to be 10. So then I need to rewrite this as 10 to some power, right? So this is going to be log of 10 to something. So we come over here and we say 10,000 equals 10 to what power? Well, look, you count the zeros. 10 to whatever power is 1 with that many zeros. Or 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. That was 4 tens. Okay? So log of 10 to the 4th. And again, the bases match. Understood 10 here, right? So the answer is just going to be 4. That's the third rule, but that's the one that's special to common logarithms because there's no base there. All right? But it's the same exact rule. It's just we have the understood base of 10. All right, so let's keep working these. Keep on keeping on. Again here, log of 10 to the 17th. Again, there's understood 10, so those match up. So guess what? If they match up, then my answer is just the power. So this is just going to be 17. And then 10 log base, 10 to the log of 38. Again, this is 10. If these match, guess what? 38 is my answer. So then this is just going to be 38. Just going to be 38. All right. ln of 1. The ln of 1. What is the ln of 1? Well, the log of 1 is always what? 0. Doesn't matter what the base is. Doesn't matter if it's ln, log base 6. Right? Log base 7, log base 11, log base 212. It doesn't matter. If it's of 1, the answer is 0. Log of 1 is always 0. ln of e to the 19. Remember, this is understood e. It's log base e. So if those match, then my answer is simply the power. In this case, it is 19. So these are your basic properties of logarithms. All right? So there are more properties, and I have a more properties video out there. And I'll deal with those properties in that video. But here, these are the basic 4 properties of logarithms that can be applied to common logs and natural logs as well, because it works for any base.